Hi, this is Paula J from CQURE, delivering another episode of CQURE Hacks Weekly. Today's episode is very special because we're going to be talking about SQL Server networking security, and we're going to focus on two deadly mistakes that are made by people who configure SQL Server in the enterprises. And today I got with me Greg and Mike from CQURE team. Greg is a specialist about enterprise security, and Mike is a specialist about SQL Server and SQL Server security. So both Greg and Mike are going to deliver the CQURE Hacks Weekly episode today for you.
Well, at my perspective, SQL Server is just a service within the operating system. It uses some networking to communicate with external parties. And I will try to cover this communication because we can spoof the communication, we can misconfigure protection of this communication. So I will play more at network layer and hacking the network layer of SQL Server security communication.
Okay, today I will show two hacks: how to get username and password, and how to bypass even more sophisticated protection inside the database when you are sniffing TDS packets.
Okay, so let's start with the first hack, and in this particular hack we will be accessing our SQL Server and we will try to get SQL Server login username and password, which is set during the authentication of the user while it's creating a connection to the SQL Server. This is standard Management Studio, and I will connect to verify that I can do this and that I have correct user to my database server. This is SQL02. I'm connecting from the Windows 10 machine. So let's connect. Currently I'm connecting as an admin using Windows Integrated Authentication. I have a secure database in which I have some tables like customers and employees. Let me go to the security, and as you can see here, I have only Charlie. I will create a new SQL login. It will be Bob, SQL Server Authentication, with some password. Mapping, okay. This time I created a Bob user and I can try to connect as this new login. SQL Server Authentication. Let me switch to the Bob and try to connect. Yes, it is possible for me to connect to the server. Of course, remember, if we are working with two connections in a single SQL Server Management Studio, always verify on which connection you are currently working. So we have secure, and I can expand it to see that I'm currently signed in here at the bottom as Bob to the secure database. Okay, so I will disconnect. This hack, to perform this hack, I will use Kali Linux, but it can be any system that can do ARP spoofing or any other attack on the network. And I will be trying to listen the network traffic that is from the SQL Server to the Windows 10 virtual machine, and from the Windows 10 to SQL Server, so both ways. Let me go and see what is the IP address of the virtual machine with Windows 10. ipconfig, and this is 10.1.1.101, and let me go to ping SQL02. This is 10.1.1.12, so this is the second IP address, and ARP-A will display information about the actual physical address of this computer that's hosting the SQL Server, and of course ipconfig/all is getting us the information about our physical address, so it's this one. Okay, to perform this network sniffing, I will be using Kali Linux, and here I have the console, and I will start performing ARP spoof. So it will be sending ARP responses to the both machines, saying that okay, this is the client and the target machine. So this is the first one. Here I'm getting it in reverse format, so actually it's client and the second one is the server. So I'm spoofing to the server and to the Windows 10 client. If I go back to Windows 10 machine and now I will display ARP -A, you will see that Linux machine and SQL2 has the same MAC address. Okay, so I'm actually changing the IP address and the MAC address for this IP address, and as you can see here, before it was actually different MAC address. So it's successfully ARP spoofing the information. So all the traffic that is going to the SQL02 will go actually to the Linux machine currently. So what I can do next, I need to set up the IP forward parameter for the Kali Linux to enable IP forwarding, and the next part is to add in IP tables additional pre-routing rule that will redirect the traffic going to the SQL02. So this is the destination port, destination IP address, and the destination port is default port for SQL Server. It will be redirecting to our local port 1433. So I'm enabling this rule, and the next part is to use MSF console. So this is actually Metasploit. It will start up in a moment. I can of course test if I can still connect to our SQL Server, connect database engine, not as Charlie, as Bob. Try to connect. Now it's not working because I'm ARP spoofing and redirecting actually with the IP tables the traffic to go directly to this Kali Linux machine. Okay, so let's go back to the Kali machine. Workspace. I'm in default, so workspace -A. Let's create a new workspace, and this is just for the demo for storing all the results. So I'm in a new workspace, and now I can search for the module, which is CQURE MS SQL. It's searching all the modules. This is actually this module which I need to use. Oops. Let's copy this one and paste it. So I'm using this auxiliary module for Metasploit, and I need to set SRV port to use default port. Okay. Now the last part is to just hit run, and it's starting listening on local port 1433. Let's try to do it. Okay. And now I'll try to connect here as Bob. Failed. But let's go back to the Kali Linux and see what we have here. We have Bob and plain text password for this Bob. I use this password to create the login on SQL Server. When I want to exit it, now I can switch to my IP tables rule and disable it. So I'm disabling this rule right now. Okay, so it's not running anymore. I can connect right now to SQL02 because I'm using IP forwarding. I can disconnect it. How I achieve this, that I can grab this password. Of course, the password is not sent in the plain text, and if I start the Wireshark, go, okay, some warnings. Okay. If I enable TDS traffic, sniffing database, let's try as Charlie. I'm connected as Charlie, and you will see that I have pre-login messages and nothing is there that I can see the password in it. It's actually not sent in the clear text password form. But what is happening when I'm using Metasploit? The Metasploit is starting a process which is showing, which is listening on port 1433 and is saying that it's very old version of the SQL Server. Actually, it's SQL Server 2000, and it's forcing the client, even the newest client 2016 or 2017 as Management Studio, to fall back to old authentication mechanism protocol. And this is when the passwords is all sent almost in plain text. So it's easy to get your password if it's possible to spoof, for example, and redirect the traffic and to force your connection to fall back to old version. Let me stop the Wireshark here. And now I will try to perform another type of the attack. The another type of the attack is very similar to SQL injection, but this time it will be not working as a SQL injection directly. Let me show you one thing here. And in TDS packets, there is plain text for actually the query. This is one of the queries that was executed on the SQL Server when the user connected with the Management Studio. So if it's possible to get this query and to change the content of this query, it will be executed with the context of the login that is connected to the server. So let's try to do it. First, we need to capture, let's say I will be doing this as an admin on the database, on the secure database. I will be doing this query. I will open it from the file. I have it on the desktop. Okay. So this is a very simple query. When I execute this query, it's getting me the results at the bottom. So to do this attack, I will run again query, TDS query, the filter on Wireshark, continue without saving, and now I'm waiting to capture some queries. So if I execute again, I should see the same query SQL batch here. This is the select, so the second one is actually this query. I will copy the value of this field. So select customer ID, company name, contact name, address, city from customers. Quite simple query. And what I will do next? I will use one of the scripts that is using ethercap to capture the packets and then change the content of the TCP/IP packets and replace the content of it for using regex to inject new query. The only thing to remember when you are trying to write this kind of scripts is that the TDS packets does not have any checksum on the query itself, but the TCP/IP packet has the checksum on the length of the data inside the packet. So the easiest way is to get very long query. This one is not so long, but it's enough to create login named hacker with the password 1. And we need to add just spaces at the end of the query to be the exactly same length as this query that we are trying to replace. I will stop the ARP spoof here on both ends. So it's not ARP spoofing anymore, because this script which I have here also is starting the ARP spoofing by itself. So just not to mess it up. So this is the same query that I copied, and if I hit enter, it's creating a payload and it's waiting for new queries. If the query is different, for example, select top one, it will not be replaced. This is SQL traffic discovered, great. So we see that we are listening for it again. But until we have the same query executed again, nothing will happen. Okay, found our string and replaced it. You see, in the SQL Server Management Studio, we do not see anymore the results for this query. If I hit again F5 to execute the same query, I will get the server principal hacker already exists. So probably someone will notice that this is a strange message when you are performing select. But of course you can change the script to end the SQL injection in the TDS packets when it's not after the first replacement. So I will exit it, and let me go to the Wireshark again. So I'm searching for this select, and of course it was found in the data here. This is the same select which was replaced with this one. So next, if I go to the logins and refresh, you will see that there is a hacker. How can we protect ourselves? First of all, it is necessary to connect with options encrypt connection. When I select this encrypt connection, the connection to the database will be protected. Again, if I open the same file and execute it, of course I need to turn on listening on the Wireshark again, so let me switch there. ARP spoofing. So I started the ARP spoofing. Again, I should see in the Wireshark the query that is executed. Okay, let's try to do this. I'm refreshing, and this time I do not see any queries here. Why is that? When I remove the filter, oops, I need to start the Wireshark again. That's this. Again, Wireshark. Okay, now I can execute the same query and go to the Wireshark to see that this time I'm starting the TLS exchange, and there is no information about any TDS packets here because they are encrypted. I do not see the query that is sender and the response. The last thing is that in this connection options, when it's encrypting, we should disable this trust server certificate. But to do this, we actually should go to the SQL Server configuration. And on the native client configuration, server network configuration, actually, this express, force the encryption and use the appropriate certificate on the list. So when we enforce this one and use the proper certificate, we can actually connect safely to our server. Remember to verify that at the bottom of the Management Studio you see the padlock that is showing that this is the encrypted connection to the server.
Okay, so after you saw 2 attacks performed by Mike, there's the time for my attacks. The first one will be very similar to the Mike one because it's about forcing SQL Server client to use clear text and then grabbing this clear text authentication out of the wire. But I will use a different cheat to make SQL Server client to connect to the SQL Server. Instead of playing on the ARP level and physical address resolution, I will work on the level of name resolution in Windows, which is significantly higher in terms of the TCP/IP stack, which also makes the attack easier to be performed. Here I have my client. I will try to ping some server, ping SQL3, and I have no SQL3 in my environment, so no one replied. If we start to think about the name resolution, how Windows client knows about what is the IP address of SQL3, we have to go to the network properties, ncpa.cpl, then to properties of the interface, and then TCP/IP, and then advanced and wins, and here you can see NetBIOS is used for name resolution. So actually, if we try to monitor this situation with Wireshark, if I launch Wireshark, I can see if I try to ping someone non-existing, ping SQL4 this time, you can see, I will stop Wireshark, you can see there is a broadcast being sent across the network with question, who is the SQL4 guy in this network? Of course, no one replied to this query, so my client returned information that host cannot be found. And to spoof an identity of different machine, will work on this level with broadcast. So I will create a process replying to such broadcast saying, I'm the one you are asking about. I will use here the responder utility, responder.exe. Originally it was Python script, but I'm using Windows version, which makes it even simpler for using by regular users, so it's significantly easier to do. So responder is sending information about fake IP addresses. This is the one thing responder is doing. Another thing responder is doing, which is really great, is acting like SQL Server. So you do not have to use Metasploit or any other third-party software. Responder itself emulates SQL Server in a way which is enough for lowering down the authentication level and grabbing the input being sent by the client. So I will run responder.exe. With parameter, it has a couple of parameters. You can easily verify those. -h should work better. I will use only one, which is about the IP address to be spoofed. The IP address of this machine is 1,200, so I will run responder -i 8,1,200, and it simply starts. Here you can see a bunch of servers being run by responder, including SQL Server. So here I have console. I return to my machine. Now I can ping. I will do ipconfig flash DNS. I can try again with SQL 4, and of course now responder sends his own IP address as a SQL 4, so it appears. And here you, in the responder console, I switch back to the responder, you can see the SQL 4 was sent to this poor victim as a poisoned answer. So having exactly the same situation and having running SQL server emulator, I can run ODBC configuration, for example. Actually, any SQL Server client will work here. I can add new connection, and I can say name will be SQL1. I will connect to my SQL Server machine. It does not matter because responder responds to any query, including this one. If I click next, I can say I would like to authenticate against SQL Server with SA account and 1, 2, 3 or whatever. Next, and I can click OK. And if I switch back here, I can see the previously captured hash for SA was in the database because I tried it previously, so I can try it with another password to make it visible. Now it connects again, and now I will try to see this, and now well, this is not I intended, so I will break it, and I will remove responder DB, the database, and I will go to logs, dir, I will remove everything, yes, and I will run a responder again, hoping this time it will grab the information from the SQL Server client. So if I click next right now, I have a connection again. I will return to my responder, and now you can see the password was really captured because SQL Server client tried to connect to my SQL Server with SA and this password. This is another thing why I did use the SA password, which is definitely not the best practice, but it is so common, I can emulate it this way just to pay attention. This is something you should really avoid in your production environment. Okay, so it was the first attack, very similar to the mic one, and at the same time a bit easier to be performed in practice. Another attack which can be performed with SQL Server or through SQL Server is not the attack on the SQL Server, but this is an attack with the SQL Server, relies on the fact then that within the SQL Server, I have it here, we can configure multiple instances. So here you can see I have my services. Here I have installed two different SQL servers running on the same machine. The SQL Server with the default or unnamed instance and with the named instance. The named instance is running. If we go for the configuration, here you can see the configuration of SQL Server services. If I open SQL Server instance 1, under properties you can see that this particular server, if you go for the network configuration, instance 1 and then TCP/IP, you can see under IP addresses there is no TCP port. It is how named instances are working in practice. Right now this is the dynamic port, but if I restart the service, if something happens, if I restart the server, the TCP/IP port may be totally different. It's a kind of a nightmare for firewall management, but this is how SQL Server is working. You can fix the port number and make it the constant one here, but by default it's very dynamic. So it is kind of an issue for the SQL Server client how to connect to the proper TCP/IP port, but because at the very end the client must connect to the proper TCP port. And on the SQL Server machine we have one very special service, which is SQL Server Browser. SQL Server Browser is kind of the librarian knowing about every single instance and then sending the information to the client. It's kind of a directory actually. So if I run SQL Server Browser service, I will start it and I will see the process ID is 4916. I can do net stat minus ANO find string /I 4916. You can see my 4196 process is listening on 1434. This is the default port. This is UDP port on which browser listens to clients. And it simply says if you want to connect to the instance named instance1, that TCP port will be this and that. And after every single restart, he will have the right information in his database, so it will send the client to the proper one. But at the same time, please do remember it's UDP based. So if it is UDP based, it may be attacked in multiple ways, actually kind of comparable to the way we attacked NetBIOS and the name resolution. Because with UDP is relatively easy to send a packet saying it's coming from totally different source, and we can use it for two purposes, such possibility of having such attack. The first one is to send packets to the poor victim acting as the victim. So let's imagine I'm doing ping saying I'm a host A, which is not true, but the reply of the ping will return to the host A because this is the source. We can do very similar thing with the UDP packets. And here with this particular service, another thing we can use is amplification. Amplification means I can send a relatively small amount of data to this service and he will reply me with something significantly bigger. And this is definitely what I can do against this particular port. I will show you GitHub repository about ms.sql.py is a Python script. I will not run it right now, but this is the script sending a packet to the SQL Server browser asking about some information and spoofing the identity of the asking party. So SQL Server browser will send back the answer. The answer will be significantly bigger, and in the same time it will be sent to the victim, to the one host identity we just spoofed. If we perform it in a proper scale, we can actually kill the performance or kill the bandwidth for this victim. So the conclusion is please do not expose SQL Server browser to untrusted hosts, especially if it's about large number of those untrusted hosts. We can find some SQL Server browsed exposed to the internet, which is not the smartest thing I can imagine, definitely. So those may be used for attacking other victims. Please care about your 1434 and about your SQL Server browser. You can remove SQL Server browser totally. Configuring your SQL Server clients with proper port number. If you do not use named instances, you also do not have to use SQL Server browser. So SQL Server browser is very handy and very comfortable thing, but at the same time, if you are security oriented, you can skip using it because it makes your environment a bit safer, but the management is significantly more complicated under such scenario. So it's up to you. So as you saw, we have a couple of attacks on the SQL Server. Those Mike presented to you. Those I tried to do on my own, very similar to the Mike one, and misusing SQL Server protocols to attack some innocent victims. All those ways can be limited, can be managed, and in a properly configured environment, no single attack like we presented should be possible in practice. So fingers crossed for your SQL Server, and please do not be scared with the SQL Server, because it's a server like any other, maybe a bit more complicated, but at the same time, in terms of the communication, is nothing really more complex than any other. Thank you.